Hey, physics fans and curious minds. Ever wondered how the universe works? Well, buckle up because we're about to take a whirlwind tour of physics. Don't worry, I promise it'll be more fun than a cat in a zero-gravity chamber. Let's dive in. First stop, mechanics. It's all about how things move and why. Picture Sir Isaac Newton chilling under an apple tree. An apple falls, bonks him on the head, and boom! We get the law of gravity. But gravity's just one of the forces that make our world go round. We've got pushes, pulls, friction. It's like a cosmic dance party, and every object's invited. Speaking of parties, let's talk about Newton's laws of motion. They're like the rules of this physics rave. First law: objects at rest stay at rest, and objects in motion stay in motion, unless acted on by an outside force. It's like how you stay on the couch unless someone yells, "Pizza's here." Second law: force equals mass times acceleration. The more mass, the more force you need to get moving. It's why pushing a shopping cart is easy, but pushing a car? Not so much. Third law: for every action, there's an equal and opposite reaction. It's not just a fancy way of saying karma. It's why rockets can zoom into space by pushing gases out the back. And let's not forget energy. It's everywhere. Kinetic, potential, mechanical, energy's the universe's way of keeping score. And the big rule? Energy can't be created or destroyed, just transformed. It's like cosmic recycling. So next time you're on a roller coaster, remember, you're not just screaming, you're demonstrating physics in action. Now let's heat things up with thermodynamics. It's all about energy, heat, and why your ice cream melts on a hot day. First up, the 0th law of thermodynamics. Yes, we started with 0. Physicists like to keep you on your toes. It basically says, if A is in thermal equilibrium with B, and B is in equilibrium with C, then A and C are in equilibrium too. It's like saying if you and your friend agree on the room temperature, and your friend and their cat agree, then you and the cat are on the same page too. The first law is a bit like your mom telling you to clean your room. Energy can't be created or destroyed, just moved around or changed. So when you're cleaning by shoving everything under the bed, you're not getting rid of the mess, just rearranging it. The second law is nature's way of saying you can't unscramble an egg. Entropy, or disorder, always increases in a closed system. It's why your room gets messy on its own but never magically cleans itself. Bummer, right? The third law? As we approach absolute zero temperature, molecular motion almost stops. It's like trying to get your siblings to be quiet. You can get close, but you'll never quite reach perfect silence. And don't forget about heat transfer. Conduction, convection, radiation. It's not just how your pizza gets cold, it's how the whole universe operates. So next time you're enjoying a hot cup of coffee or complaining about a cold shower, remember you're experiencing thermodynamics in action. Now let's spark things up with electromagnetism. It's the force that powers your phone, keeps magnets on your fridge, and makes lightning look cool. First, let's talk charge. Positive, negative, it's like a cosmic dating app. Opposites attract, likes repel. It's why your hair stands up when you rub a balloon on it. You're playing matchmaker with electrons. Now imagine if we could measure the force between these charges. That's where Coulomb's law comes in. It tells us that the force between two charges is proportional to their magnitudes and inversely proportional to the square of the distance between them. In simpler terms, the bigger the charges and the closer they are, the stronger the force. It's like gravity, but for electric charges. But what if we have a whole bunch of charges? That's where Gauss's law saves the day. It's like a magic bubble that helps us calculate the electric field for symmetrical charge distributions. Imagine throwing a net around an electric charge. Gauss's law tells us how much electric field is poking through that net. It's super handy for solving tricky electromagnetic problems. Enter Michael Faraday, the rock star of electromagnetism. He figured out that changing magnetic fields create electric currents, and vice versa. It's like finding out your peanut butter can make jelly, and your jelly can make peanut butter. This led to Maxwell's equations, the superheroes of electromagnetism. They explain how electricity and magnetism are actually two sides of the same coin. It's like finding out Batman and Bruce Wayne are the same person, but way cooler. Thanks to these discoveries, we have electric motors, generators, and even light. Yep, light is just an electromagnetic wave. So next time you're taking a selfie, remember, you're capturing electromagnetic radiation bouncing off your face. How's that for a glow up? And let's not forget about conductors and insulators. Conductors are like gossipy friends, passing along electrical charge easily. Insulators are more like that friend who never checks their messages. So whether you're switching on a light, making a call, or watching this video, you're harnessing the power of electromagnetism. Pretty shocking, right? Now let's get weird with modern physics. We're talking Einstein, quantum mechanics, and stuff that'll make your brain do backflips. First up, Einstein's special relativity. He figured out that time isn't constant. It can stretch and squeeze like a cosmic rubber band. The faster you go, the slower time moves for you. So if you want to stay young, just travel at the speed of light. Oh wait, you can't, sorry. Then there's E equals sine mc2. Energy equals mass times the speed of light squared. It's why stars shine and why a tiny bit of mass can release a huge amount of energy. It's also why eating that extra slice of pizza can feel like it's doubling your mass. Now let's shrink down to the quantum realm. Here, things get so strange that even Einstein called it spooky. Particles can be in two places at once, cats can be alive and dead at the same time, and everything's just a probability until you look at it. It's like having a fridge that contains every possible leftover until you open the door. Quantum mechanics is why your computer works, why stars don't collapse, and why scientists have the best party tricks. And let's not forget about the hunt for the theory of everything, the physicist's holy grail. We're trying to unite all the forces of nature into one elegant equation. It's like trying to get all your friends to agree on a pizza topping, but on a cosmic scale. So next time someone says it's not rocket science, you can say, you're right, it's quantum physics, and watch their minds explode. But only if you observe them, of course. And there you have it, folks. We've just taken a whirlwind tour through the wonderful world of physics. From the apples falling on Newton's head to the mind-bending realm of quantum mechanics, we've covered it all. So the next time you're out there in the world, take a moment to appreciate the physics all around you. Until then, stay curious, keep questioning, and remember, the universe is your playground and physics is the rulebook.